Picking up on the previous video, again, this idea of the vertical cross sections that are perpendicular to the region that we've got between either the function and the x-axis or the function and the y-axis, or it could even be the area between two functions. It gets a little abstract, and that's why you have that picture in the notes there of the hat shell up on the esplanade. And the idea of if we had a whole bunch of semicircles sort of stacked right next to each other, then we could actually recreate the volume or find the volume of the hat shell itself by just adding up the areas of all of those semicircles that are right next to each other. And that's the idea with this volume by cross sections which are perpendicular to the base. All right. So we're finding a sum, and that's leading us again to the definite integral. All right. But what are we finding the sum of? We're finding the sum of the areas of all these shapes. Okay. So again, if we try and look at that idea, all right, if we have just one curve and we're dealing with the x-axis, all right, so then we've got this shape where the base is the perpendicular to the x-axis. So in other words, that purple line right there is the base of our geometric shape. Now, which shape it is, we'll get to in a moment. But the idea is that basically coming out of the board is some kind of shape. Maybe it's a square, maybe it's a rectangle, maybe it's a semicircle, but it's actually coming out towards the screen. All right, so it could be perpendicular to the x-axis, or it could be perpendicular to the y-axis. All right. But ultimately, we've just got a whole bunch of, let's just say, semicircles coming up off of the board, out towards us. All right. If we find the area of all of those semicircles, right, because sometimes the semicircles will be rather large. Where's my marker? Sometimes the semicircles might be rather small. All right. But if we find the area of all those semicircles, we add them all up, then we're going to get the area of whatever it is, that region that's popping out of the screen. I'm sorry, the volume of the region that's popping out of the screen. And that's what we're doing right there. We're adding up a whole bunch of areas. All right? We're adding up a whole bunch of areas. If it's perpendicular to the y-axis, then we need a function in terms of y. If it's the x-axis, a function in terms of x. If there's two functions, all right, now we've got a whole bunch of rectangles coming off the board, and all the rectangles, the base of the rectangle is in between our two functions, the green and the orange curves right there. So again, it might be a very small rectangle that's barely coming off the board, or it could be a rather large one that's coming off a good amount. But if we find the area of each of those rectangles and we add all those areas up, then we're going to get the volume of that region, of that solid. Okay? Same thing, could be perpendicular to the y-axis as opposed to being perpendicular to the x-axis. Again, no big deal. We're just going to find our area in terms of y as opposed to being in terms of x. Now, because there's two curves, there's going to be subtraction involved again. You know, we have our top curve minus our bottom curve. That gives us the length of our base. So it's similar concepts as with the area between two curves, or the volume when a region between two curves is revolved around a certain axis of revolution. All right, now as far as the shapes are concerned, well, the shapes that we want to be prepared for in the BC course would be squares, rectangles, semicircles, and then isosceles right triangles and equilateral triangles. All right, the equilateral triangles is really only a BC shape. The other four would be AB, BC. Okay, and it actually doesn't even have to be a shape itself, but they could tell you what the area represents. We'll get into that more in a future video as well. But the idea is be ready for how to come up with the area of these shapes and how it's connected to our area formula as far as our sums are concerned.